Dear students, welcome to my first class on Module 2, Fourier series. In this lecture video, we're gonna discuss about periodic functions and Dirichlet's conditions. What is periodic function? A real valued function f of x is said to be periodic of period capital T if f of x plus nt is equal to f of x for all t is greater than 0. Example, the trigonometric functions like sin x and cos x are periodic with period 2n pi. Similarly, tan x is periodic with period 2n plus 1 pi, and also the constant is periodic with any positive period of pi. Dirichlet's condition: a function f of x defined in the interval c less than or equal to x less than or equal to c plus 2 pi can be expanded as an infinite trigonometric series of the form with the following condition. The first condition is f of x is single valued and finite in the interval c comma c plus 2 pi. F of x is continuous with finite number of finite discontinuities in c comma c plus 2 pi. Third condition is f of x has no or finite number of maxima or minima in the interval c comma c plus 2 pi. Definition of Fourier series. Fourier series for the function f of x in the interval c less than x less than c plus 2 pi is given by the expression f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity bn sin nx. So where this a naught, an, bn are called Fourier coefficients, and it is defined like a naught is equal to 1 by pi integral c to c plus 2 pi f of x dx, an is equal to 1 by pi integral c to c plus 2 pi f of x cos nx dx, bn is equal to 1 by pi integral c to c plus 2 pi f of x sin nx dx. So now we shall discuss what is odd function and even function. So odd function, a function f of x is said to be odd with the following condition. The condition is given by f of minus x is equal to minus f of x. So this will be, so example is x, x cube and sin x etc. will be treated as an odd function. Similarly, even function, a function f of x is said to be even with the following condition. The condition is if f of minus x is equal to plus f of x, so then we will be calling those kind of function is an even function. For example, x square, cos x, sin square x etc. will be treated as an even functions. So Fourier series expansion over the interval minus pi comma plus pi. The formula is given by f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity bn sin nx. So in this formula, to find a naught, an, bn, we have to use the following formulas. So a naught is given by 1 by pi integral minus pi to plus pi f of x dx. An is equal to 1 by pi integral minus pi to plus pi f of x cos nx dx for n is equal to 1, 2, 3 and so on. Bn is equal to 1 by pi integral minus pi to plus pi f of x sin nx dx for n is equal to 1, 2, 3 and so on. So here this so now we'll be falling into two cases. The first case is if f of x is an odd function in the interval minus pi comma plus pi. So if the function is odd function, so directly we are writing a naught will be equal to 0, an is equal to 0, only bn will be finding. So to find the value of bn in this case, the formula is 2 by pi integral 0 to 5 f of x sin nx dx for n is equal to 1, 2, 3. Second case, if f of x is an even function in the interval minus pi comma plus pi, so in this case only bn will be 0. We are supposed to find a naught and an with the following formulas. The formula for a naught is 2 by pi integral 0 to pi f of x dx, an is equal to 2 by pi integral 0 to 5 f of x cos nx dx for n is equal to 1, 2, 3 and so on. The problems on the interval minus pi comma plus pi. Obtain the Fourier expansion of the function f of x is equal to x over the interval minus pi comma plus pi, and also deduce that pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on. So first we need to verify the function is order even. Okay, given f of x is equal to x and the formula is given by f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos n x plus summation n from 1 to infinity b n sin nx. Call it as equation number 1. So now I am going to verify the function is an odd function or even function. So just replacing x is equal to minus x in the given function f of x, will be getting f of minus x is equal to minus x, it will be equal to minus f of x. So hence the function x is an odd function. The function is odd function means only a naught a n will be 0. We have to find only the value of bn. So now we will find bn. So bn is equal to, the formula is 2 by pi integral 0 to pi f of x sin nx dx. So in the place of f of x I am going to replace x here. So we'll be getting 2 by pi integral 0 to pi x sin x dx. So to solve this one I am going to apply the Bernoulli's condition, taking x as u algebraic term and sin nx as v function. So now I am going to apply the Bernoulli's condition. So the constant 2 by pi I will keep as it is. So first is keeping x term as it is, integrating only sin nx, will be getting minus cos nx by n minus. So now solving x with respect to x one time, so it will become 1, and solving this cos nx one more time, will be getting minus sin nx by n square with the limit 0 to pi. Okay, now I am going to apply the limit. Applying upper limit, replacing all x terms by pi. So we'll be getting 2 by pi as it is, minus pi cos n pi by n plus sin n pi by n square minus, now lower limit, replacing x is equal to 0, I'll be getting 0 into cos 0 by n plus sin 0 by n square. So as you know that sin n pi value is 0 and sin 0 also 0, and so this term also will become 0. So only I'll be getting minus pi cos n pi by n, and cos n pi value is minus 1 power n. So we'll be getting 2 by pi minus 1 power n by n. So pi gets cancelled. So we got bn is equal to minus 1 power n plus 1 by 2 by n. So now this bn value along with a naught is equal to 0 and a is equal to 0, I am going to replace in equation number 1. So we got f of x is equal to 0 plus summation n from 1 to infinity 2 by n minus 1 power n plus 1 sin nx we got. So finally x is equal to 2 into summation n from 1 to infinity minus 1 power n plus 1 sin nx by n is the required Fourier series. So to find the next part, I am going to replace here x is equal to pi by 2. So in the above expression, I will be replacing x is equal to pi by 2. So after putting x is equal to pi by 2 on both the sides, I got pi by 2 is equal to 2 into sin pi by 2 minus sin 2 pi by 2 by 2 plus sin 3 pi by 2 by 2. So we got this expression, and as you know that, so now after replacing this value, so here it will become sin pi, as you know that sin pi will become 0. So we got the equation like this. So pi by 4 is equal to 1 minus 0 plus 1 by 3 into minus 1, because sin 3 pi by 2 is minus 1. So next value will be 0 and so on like that. So finally after simplifying this, we got the equation like pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on is the required solution. Example number 2, expand f of x is equal to square root of 1 minus cos x in a Fourier series over the interval minus pi comma plus pi. So first as usual, take the formula f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity b n sin nx. Call it as equation number 1. So now we need to verify the given function f of x is equal to square root of 1 minus cos x is order even. So same like a previous problem, replace x is equal to minus x. So after checking, so we got this square root of 1 minus cos x is an even function we got. So since the function is even function, only bn will be 0 in this interval. So now our job is to find the values of a naught as well as an. So now to find the value of a naught, the formula is 2 by pi integral 0 to pi f of x dx. So in the place of f of x, I am going to replace square root of 1 minus cos x. So now to simplify the square root, I am going to replace 1 minus cos x as 2 sin square x by 2. So we got the equation like this. That is 2 by pi integral 0 to pi square root of 2 sin square x by 2 into dx. So the square root of 2 I am taking outside, square and square root gets cancelled. So we got 2 into root 2 by pi integral 0 to pi sin x by 2 dx we got. Okay, now I'll be replacing x by 2 is equal to t. It implies dx by 2 is equal to dt, or dx is equal to 2 dt will be getting at x is equal to 0. So t will be 0. At x is equal to pi, t will become pi by 2. So now I'm going to replace this entire data in the above expression. So we got a naught is equal to 2 root by pi into integral 0 to pi by 2 sin t 2 dt, or 4 root 2 by pi integral 0 to pi by 2 sin t dt. So now after integration, the constant 4 root 2 by pi I'll keep as it is. Sin will become minus cos t, the limit 0 to pi by 2. Applying the limit, we got 4 root 2 by pi into minus cos pi by 2 plus cos 0. Cos 0 is 1, cos pi by 2 is 0. So the value is a naught is equal to 4 root 2 by pi is the required solution for a naught. So now in the same way we'll find an. So the formula for an is 2 by pi integral 0 to pi f of x cos nx dx. So same thing here also, I'm going to replace f of x as square root of 1 minus cos x, and replacing 1 minus cos x as 2 sin square x by 2. Like after simplifying all these equations, we got the equation like 2 root 2 by pi integral 0 to pi sin x by 2 cos nx dx. So now to simplify this one, I'm going to use sin a cos b formula. So after applying the formula, we got the equation like 2 root 2 by pi integral 0 to pi 1 by 2 into sin n plus 1 by 2x minus sin n minus 1 by 2x into dx. After integration of sin, I'll be getting root 2 by pi, I'll keep as it is, minus cos n plus 1 by 2x by n plus 1 by 2 minus of minus cos small n minus 1 by 2 of x by n minus 1 by 2 with the limit 0 to pi. So now after applying the upper limit, the first two terms will become 0 for upper limit, and lower limit replacing x as 0, we got cos 0 by n plus 1 by 2 plus cos 0 by n minus 1 by 2. As we know that cos 0 is equal to 1, so we got the equation like root 2 by pi into 1 by 1 n plus 1 by 2 minus 1 by n minus 1 by 2. So take LCM over here. So we'll be getting root 2 by pi n minus 1 by 2 whole divided by n plus 1 by 2 into n minus 1 by 2. So after simplifying this, we got root 2 by pi into minus 1 divided by n square minus 1 by 4, or minus root 2 by 5 into 1 by 4 n square minus 1 divided by 4. So finally we got the equation of an is minus 4 root 2 by pi into 1 by 4 n square minus 1. So now we will be replacing this a naught, an, bn in the equation number 1 in the main formula. So like after simplifying, we got the answer like square root of 1 minus cos x is equal to 2 root 2 by pi into 1 minus 2 into summation n from 1 to infinity cos nx by 4 n square minus 1 is the required solution. Thank you.